Hey everybody, hopefully you'll be able to hear me well enough. I am sorry, but my son Bryce is sick, and so I am kind of doing some plans at the last minute. If we are all good and we watch the videos today and take our notes, then I suppose we will not have any homework. For number 1 of your jump start, you need to factor using the difference of squares. You have an x squared and a 25. So the two of them factor into x plus 5 and then x minus 5. If we look at the second problem, we have an x squared plus 25. While both of these are perfect squares, we don't have a sum of squares. We only have a difference of squares. So the answer for number 2 is prime. And my writing is going to be bad because I do not have a Mimeo board at home. I'm just doing this with the mouse, so I apologize. For number 3, we have the difference of cubes. 125 simplifies into 5 times 5 times 5, or factors into 5 times 5 times 5. And so if we remember, this is x minus 5, and then we have x squared plus 5x plus 5 squared, which would give us 25. Number 4 is the sum of cubes. Remember that the first one matches, so we have x plus 5. However, we have to have a negative somewhere. So in this case, our negative is going to be next. It's going to be x squared minus 5x. That negative allows things to cancel out, because if you multiply a binomial times a trinomial, you have to remember that we have 6 terms. So if there's not a negative, then other things will not cancel out. Sorry. And then for number 5, we have a cube and we have a minus, so that works, but 25 is not a cubed number. 25 just factors into 2 and 2. I don't have 3 of those. I mean, pardon me, not 2 and 2, 5 and 5. I only have a pair. I don't have 3. So we are going to have to leave this as prime. Now, if we look at the word problem, the perimeter of the rectangle is given. If we draw our rectangle, and we know that our length is 2x squared plus 3, and this is 2x squared plus 3, then what happens is we need to find something that is going to equal a total of 10x squared plus 20x. So I'm going to combine these two, and I'm going to take my 10x squared, this is my perimeter, this is what I'm starting with, plus 20x, and I'm going to subtract these two sides. We know that if this is the total perimeter, we have to get rid of these in order to find the two opposite sides. And since it's a rectangle, these two are equal, so when we subtract the 4x squared plus 6, once we do that, then we can divide by 2. So we actually have to subtract 4x squared plus 6. And I'm sorry, I'm at home. I'm sure you just heard, if you heard commotion, that was Touchdown, our dog. So oh, that should be a 6, not a 3. And when I subtract these, I'm going to be left with 6x squared plus 20x sorry, flustered, and then a minus 6. Now this is the area that we need. This is what we need left. It's not area. This is the measurements that we need left, but it has to be split between 2. So actually the width is going to be half of this. So if we divide this polynomial by 2, then we're going to be left with 3x squared plus 10x minus 3. If you were to add 3x squared plus 10x minus 3 to another 3x squared plus 10x minus 3, that's how you would get your 6x squared plus 20x minus 6. And then if you were to add the 4x squared plus 6, which is both of these added together, then the positive 6 and the negative 6 will cancel out, and you'll get your 10x squared plus 20. Hopefully you see that. Today we're going to take some notes on rational exponents, and so you need to go ahead and get out your notes. I'll give you just a few seconds to do that. So today we're going to discuss rational exponents, and the word rational should let you definitely think of a fraction. Rational exponents means that we are going to represent our exponents that are in fraction form. First of all, we need to look at 2 rules, so let's write these down. If you have b to the 1/nth power, you have b to the 1/nth power, then that is going to be equal to the nth root of b. I'm going to try to write that a little better. The nth root of b. Basically, if you had b squared, that squared would be in the numerator, so that means you have b times b. However, if you have b to the 1/2, that means you're taking a root. You're not squaring it, you're doing the opposite. You're taking the root. You can also have b to the x over y. So this is another rational exponent. The numerator is actually going to tell you what power you are raising it to, and then the denominator is your root. So this means you're going to have the y root of b to the x. So these are the 2 main rules that we're going to use today, along with our monomial rules, which we already know. Hopefully the video last night helped you. I am going to check both videos tomorrow, and both video notes that haven't been checked. So please, please, please make sure that you have those completed. If you did not watch the monomials video last night, you want to watch that to make sure that you are good with your exponent rules. So this says to write, our directions tell us to write each expression in radical form, or write each radical in exponential form. So if we just have a 1 in our numerator and a 6 in the denominator, then what this means is that we want the 6th root of 3. This is just telling us to find the 6th root of 3. Honestly, you would have to have 6 3 for, excuse me, you could do anything about that. So we are just going to have to leave that as the 6th root of 3. If we go to number 2 and we want to find the 5th root of 8, our denominator is 5, so that's going to be our root. Our 8 is only raised to the first power, so there's really nothing we can do there. We can factor 8. It does factor into 4 and 2, and then 2 and 2, but that really doesn't help us because that only gives us 3 2's, and in order for us to simplify this radical, we need 5 2's. So we're just going to have to leave it as the 5th root of 8. This tells us to write each expression in radical form or write each radical in exponential form. So on number 3, 4, and 6, we're going in the opposite direction. If there is no number in our radical, we know that that means it is a square root. And so we take what is underneath the radical. It is raised to the first power. So we just write it as 51 to the 1/2. Looking at number 4, we do have a 15 cubed underneath the radical, so that cube is going to be our numerator, and the 4, which is our root, is going to be our denominator. I'm going to skip to number 6 while we're on a roll. Here we're changing from radical form to exponential form. So we have our 37. It is not raised to any power underneath the radical, so that means our numerator is going to be 1 and our denominator is the root, so it's going to be 37 to the 1/3. These problems aren't taking very long at all. That's good news. Looking at number 5, what this shows us is that we are going to be the 3rd root of 12 squared. Now, we can look at this 2 different ways. We can write the factors of 12 and then double them. Our factors of 12 are 4 and 3, and then 2 and 2. And so if we have that squared, then we have another 2 times 2 times 3. And if we want to take the 3rd root, we actually have 1, 2, 3 2's. So we can bring that 2 out in front, and then we would be left with the 3rd root of the 3 times 2 times 3, because I don't have enough 3's to take a 3rd root, so that would actually be 18, because 3 times 2 is 6 times 3 is 18. So if you wanted to simplify that radical, you could. I'm going to hopefully finish these 2 up. Here we have a power raised to a power. Hopefully you remember, like from the notes last night, if you have x to the 3rd raised to the 4th power, we multiply those until it becomes x to the 12th. If we have a power raised to a power here, this would be c to the 3, and if you had to write it as a fraction, it would be 3/1 raised to, and I guess I'll finish this